So in this video, I'm going to talk about this zeroth law of thermodynamics. Altogether, there's 4 laws starting from 0, 1, 2, 3. This is called the zeroth law because they thought of the first 3, then they realized this is the underlying factor which makes the other 3 possible. So that the zeroth law says if these are 3 systems. So if C is at thermal equilibrium with A and B, then that must mean that A and B are in thermal equilibrium with each other. So let me show you an example of that. So here we have 3 systems, A, B and C. So we put it in a chamber. This blue thing is just like a bubble, around insulating bubble, so no heat can escape or enter, so it's like an insulator. And we have 3 systems here. Also, this is an insulator as well, so A and B do not touch. This actually should go all the way around. Yep. So that's the insulator, and in between A and B we have a conductor. So the law states that if C is at thermal equilibrium with A and B, that must mean A and B are in thermal equilibrium with each other. So that we put insulator between A and B. This is the insulator, and so they don't touch, so there's no heat transfer. Then we put a conductor which lets heat enter A and B, and then we leave it for a while, and this shows that C, if it's at thermal equilibrium with A and B must be in thermal equilibrium with each other. And experiments show, so if we do that first, and secondly, then we switch it around. For example, now this is the conductor, and that's the insulator. So experiments show that when we do this, now no heat is going to C because there's the insulator, but now heat should flow from A to B, but then when experiments show that there is no heat flow, so that must mean they're in thermal equilibrium with each other. So therefore this shows that temperature is measurable quantity. So this leads to the temperature scale such as Celsius scale, Fahrenheit scale, the Kelvin scale, which I'll cover in the future videos. So thanks for watching, hope that was clear.